knowledge translation model we call knowledge to action. How do you take scientific knowledge and get it placed into actual practical use? And I see the model, and they had one version was called the end of grant model. So you do whatever you're going to do, and then you wonder, might anyone use this? You could go look for someone who might use it, which obviously is the least efficient approach. And they had a second version called integrated, where you as a scientist decide what you want to research, and once you decide to start your work and get your money, now you maybe bring in some of the stakeholders. Okay, a little better. But if we're talking delivering products to the marketplace, those people should be helping you determine what you're actually going to do. Do we really need the research? So we actually created our needs knowledge model we call the prior to grant model. Before someone even gets the money, before you even start doing research, you first say, what is the problem? And you validate the problem. You validate on a global level that it's an unmet problem. Then you specify your potential solution. And then you verify that your potential solution is feasible in reality. Only after you do those two things that you ask the question, do we need to know anything from science that we don't already know? Only then, if so, you design a study, whether you're studying, I don't know, nanotubes or whatever you might need. If you do truly need something that doesn't exist in aerospace or automobiles or military, if it's not out there, then okay, there's justification for doing basic research. Otherwise, why would any of the money go to just research? And the same would be then said, okay, if we don't need to do anything new, we have to spend time finding and acquiring that knowledge that we need that we don't know, but it exists out there. So you have to engage this with technical knowledge to tell you what you need to know. So then you move from the science discovery to engineering, and again you say, do we need, what do we need to do to build this thing? Or are all the components already there? Maybe there's a beta prototype just waiting to be brought to market. Then maybe we do need to put money in engineering, maybe we don't. If you don't need to put money in R or D, go directly to supporting industry to deliver the product as it is or deliver a better product. So it's all, starting with a logic model, what are we trying to accomplish, what social and economic impact that we intend to achieve, then you can start working backwards and see how far back in the process, how far back in the states of knowledge we need to go to accomplish the results. Now, Japan, the Asian tigers, pretty much everyone has followed this traditional model that I talked about here because it seemed to be working and there was a lot of money, so they all followed. The only break I see right now is China. If you look at China's 2050 plan for technological innovation, China is expressly differentiating. They're saying we have scientific research that generates conceptual discovery. I mean, it's pretty much the language we're using. We're saying we have three types of activity. We need to conduct all three to the extent necessary. But technological innovation in China, according to the 2050 plan, will be driven by industry requirements and market opportunities. That's what the 2050 plan says. And when I read that 2050 plan, I said, we are totally screwed. They already have all of our debt in the United States. They've cornered the world market on rare earth materials in Africa and Asia. Now they're going to go after the products. I mean, it's almost game over. We're not in the last quarter. We're in bonus time here. And it's like, if we don't change the direction of our approach to things, if they do it right and everyone else is doing it wrong, I don't need to explain the results. So it might be interesting. You might want to look at the 2050 plan. Now, I talked to people who understand it much better than I do. There's questions of whether it can be implemented, whether the society will allow it. But they now have, I think, the right thing. And I think OECD is going along this correct track by now saying, okay, we can't use the word innovation when we're talking about science anymore. We need to talk about innovation in the context of market opportunities that generate new net wealth. Now the U.S. Science Board adopted that same definition, so that I'm seeing a gradual shift in perceptions. And I think only because the money's trust. And when I say people, I say, you don't have to change, but the change is coming, whether you change or not. And I feel that I'm not going to see the results of the difference in the policies, but the younger people in this room will. And that's why I wish we could do it in a way that delivers, new net wealth by delivering value to products and services. And for any program that government funds, it's held to the standards. So for these kinds of programs, you need the metrics. You need to make sure that the metrics are there to track the activity. And you can't just treat it in Canada. A grant is considered a gift. Once it's allocated, they have no more control. In the U.S., in the National Science Foundation, they do some monitoring, but the monitoring at NSF is only to ensure that the quality of the science is high. But these hybrid programs are something very different. So those standards, neither of those standards are appropriate. We have to know whether the public, people say, do you know where this money came from? It came from the private sector. It came from profit, from companies, and it came from the taxes paid by the employees. And they say, well, money given to universities there's a multiplier effect. You know this term, the multiplier effect? Last year, the U.S. Chronicle of Higher Education was writing an article on the multiplier effect. Someone has a great idea to have the author of the article call me. What do you think about this multiplier effect? And I try to explain, if we take $1, we collect $1 from the taxpayer, and we give it to the Congress, and the Congress allocates this $1 to this program. And that program allocates it to the university. The university allocates it to the professor and the students who work on the project, and then they take a portion of the $1 and they go out and they pay for their home and their cars. And then a portion of that money from their income is paid back to the government, but only a small portion. They said, you understand it's the same $1. You can't count it every time it changes hands. It's $1. And I had this long pause, and he says, so, you're anti-science. He did the same. He said, that's not the point. But it's incorrect to say it multiplies. It's a closed system that loses it. The multiplier effect comes from new net wealth, whether you're talking about from a person, or a company, or a university, or a state, or a country. If it's not coming from outside that system, it's not new net wealth. It's just circulating inside. So if China's 2050 plan works, and they can stick a big straw in our economy and start sucking the money out, guess who gets the new net wealth? China. And we continue to contract. And I think that's true for any country. It's all a matter of the net wealth in the context of market commercialization, which is why these governments and policy boards are going to say, oh, this is a problem. And it's only because it truly is, the problem is not coming, it's here. And what happens in 30 years will make the determination of the difference what happens. We can only do what we can do in the meantime, but we can certainly call the question when we're hearing something that just doesn't make common sense, basic sense. So I hope that answers that. I hope it's useful at some level. And again, I thank you for spending all this time with me today. I hope it's useful, and maybe I'll see you at Reatech. Tomorrow we'll do a workshop on the details of the needs knowledge model. It won't be on this. I thought for your group we should take it to a higher conceptual level and talk about sort of the foundational issues. So I hope it was useful.
Então, para finalizar, eu gostaria de destacar que foi especialmente esclarecedora, na fala muito interessante e muito rica, não é, do professor Lênin. Foi muito esclarecedora essa distinção entre os 3 campos de conhecimento. E em uma frase eu gostaria de dizer que, à medida em que a gente compreende melhor, não é, o papel da ciência, das descobertas conceituais, o papel da engenharia com o desenvolvimento dos protótipos e o papel da indústria na produção dos produtos, a gente também melhora a nossa interação com cada um desses campos e a gente corrige, por assim dizer, a nossa expectativa para com cada um deles. A gente sabe melhor o que esperar de cada um desses 3 campos. Então eu penso que essa palestra tenha sido particularmente enriquecedora para o CNRTA, na medida em que o CNRTA articula e tem inserções em cada um desses 3 campos. E também eu gostaria de destacar que eu fico muito feliz por essa menção ao protagonismo das próprias pessoas com deficiência, dos usuários da tecnologia assistiva, na melhoria de todos esses processos. Eu penso que nós, que temos alguma deficiência, temos um papel muito importante no dia a dia para que as coisas de fato aconteçam, para que as pessoas tenham mesmo uma qualidade de vida cada vez melhor. A gente é parte, não é, dessa história, a gente é parte ativa desse processo. Então eu fico muito feliz por poder ter estado presente aqui nessa palestra hoje e agradeço a todos vocês, e especialmente ao professor Lane, por essa troca, por essa partilha de conhecimentos conosco e por essa imensa disponibilidade. Seja sempre muito bem-vindo aqui no CTI.
Certinho?
Tudo certo. Você que é o